how interesting it is. Second, because I didn't want accidentally to reveal stuff that is our proprietary information. Okay, please let me know if the screen works out okay, because I know that GoToMeeting has some resolution issues and I have a very large screen. So I tried to make it small, the window small. So I hope you could see it, right? So right now we're on slide 2, says sentiment analysis, a definition. You can see it, right?
Yes, we do.
Perfect, okay. So our biggest problem for the first year and a half when we started the company was explaining to people what it is that we do. What is sentiment analysis? Nobody really in the mainstream knew what it was. So we started looking for definitions, and there are several definitions. Some are nice and elaborate and very nice sounding. Some are more functional. So sentiment analysis or opinion mining is a broad area of natural language processing that aims to determine the attitude of speaker or writer with respect to some topic. And that's semi-obvious. Sentiment intuitively is how we refers to our opinion toward something, right? So toward the topic. There are some other extensions to this definition. People could be talking about judgment. Emotions are getting more and more into play because the core, the base sentiment analysis these days is largely considered to be a commodity. There are dozens of companies that do sentiment analysis. There are probably hundreds of toolkits that people could use, and everybody understands slightly different things, and everybody does emphasize slightly different angles. So this is our functional definition. Sentiment analysis is an automated way of quantifying polarity and intensity of opinion toward the topic. And as I said, sometimes we add emotions because these days the border between sentiment and emotions in the industry is getting increasingly less defined. Why? Right? So why do people do that? Again, intuitively, it's more or less clear. Right? The internet is this huge, great echo chamber. There's a lot of data. People go and express their opinions, whether when anybody asks them or not. And the assumption is that statistically, the majority of people, when they express their opinions, they actually do express their opinions rather than trying to make either a political point or trying to get some advantage. So there are many applications for technologies that could evaluate this, let's assume, honest set of opinions out there on the internet. Financial markets. Today, with the advent of automatic trading, companies are looking for any possible, however tiny, bit of advantage. So if somebody could, in real time, real quick, real fast, analyze what people are talking about, what people are saying about a particular stock, their attitude toward that, it may actually affect the trading policy. It is, in a way, self-fulfilling prophecy. If somebody influential says, guys, my advice to you is dump Disney. Obviously, Disney stock will go down. But again, if you look at the internet as a whole, it's a huge, huge, huge world. Yes, there are several influential people on any topic, but then there is this vast number of people who represent the quote-unquote wisdom of the crowds. And that's what the sentiment analysis is about. It's one of the ways in which people are trying to harness this wisdom of the crowds. So other than financial markets, consumer companies are interested in what people are saying about their products. Organizations and government offices are interested in what people are saying about policies. Our very first paying customer back in 2007 was the World Bank. And they wanted to know what people around the world, in this case, I guess it still means the internet, even though it was less developed back in 2007. They wanted to know what people were saying about two topics. They weren't interested in details of any individual policy, but they wanted to know what people were saying about the World Bank itself as an organization. And they wanted to know what people were saying about the president of the organization. So amazingly enough, there was enough conversation going on online about those two topics. So we worked with them for probably 3 or 4 years before the president changed, and then their priorities changed as well. So multinational organizations that are spread around the world may be interested in learning how people perceive them in the corresponding countries. And obviously, politicians are prime candidates to be sentiment analysis software customers, because they want to know how their positions are being viewed by the population. This is kind of the standard pitch that you give when you approach a potential customer. You're saying there are millions of consumer conversations online containing hundreds of millions, if not more, of opinions. Don't you want to know what people are saying about you, about your products, about the competitors, what they like, what they don't like, about the stuff that you do? How do you compare? How do your products compare to that of your competition? There are other tools, obviously, to do that. There are opinion polls, and so on and so forth. But my best comparison here is it's like opinion polls compared to sentiment analysis of the internet opinions is like watching animals in the zoo versus animals in the wild. In the zoo, you will get probably the prime specimens, right? Carefully selected and kind of more used to being observed. And that animal will display some sort of behavior that will be related to what this animal does in real life, in the wild. Whereas sentiment analysis allows you to monitor that particular animal in the forest, in the wild, and in the native environment. So the reactions that you observe are much more natural, and the behaviors that you observe is a better representation of what this animal typically does, right? And when you are applying this to consumer behaviors, you are not only interested in focus groups, because people who are participating in focus groups are in a way under pressure because of the very fact that they have been selected, moved somewhere, and asked specific questions. So another tagline that we use with a varying degree of success is that the answers to all your questions are out there on the internet. What our software does, and what other sentiment analysis software does, is providing you the tools to ask the question. The answer is there. You just need to know how to ask the question, and we'll help you with it. So there are two general approaches to sentiment analysis without going into extremely technical details. One is pure linguistic approach. Your software identifies what is called opinion carrying expressions, or opinion expressing constructs. For example, the construct was really good, right? It's here it's a very simple example, so it's easy to see that really good is carrying an opinion about the concert. Obviously, again, in real life, the situation is a little bit more complicated. When you see something like this example, you just consider yourself lucky because this is simple. There is another approach called reasoning approach, where you are trying to analyze text which doesn't necessarily carry an opinion, but could play a role in shaping an opinion of a person who reads this, right? So, for example, if somebody says a car runs 10 miles per gallon, right? So whatever it is in kilometers and liters, it doesn't necessarily express an opinion. And whether or not this is a positive or negative description of the particular car and fuel economy depends on several factors, in particular on what kind of car it is, right? So if somebody says, you know, this truck, it weighs 15 tons or 10 tons and it can do 10 miles a gallon, it's good. If somebody is talking about an economy car, like Honda Civic or some small Fiat, 10 miles a gallon is not good. So you need to know the context in this situation. Another example, opposition leaders in Venezuela staged massive protests in response to government price hikes. It doesn't express any opinion about the Venezuela government policies. It doesn't it doesn't indicate directly what writers think about, what the writer of this text, the author of this text thinks about the government policies, about the price hikes. But obviously, the very fact that there are protests and that they're massive indicates that the opinion of the government policies is, generally speaking, negative. So reasoning is required in this situation. And you know, both approaches have their strengths and their weaknesses, and typical solution, a typical advanced solution needs to integrate both, because you know, at the end of the presentation, I'll go over some of the challenges that remain, and we'll understand better why this sentiment analysis problem, sentiment analysis task is a commodity, but it's not, it cannot be completely solved yet. So let's go and look at some example, like a sketch of an algorithm. It's not a real algorithm. It's basically how our internal software looks at things. For other vendors, the approach may be differing in a variety of ways, but the general approach probably stays the same. So how does the typical, how does the sentiment analysis software work? Given a document and a search term or a topic, it's supposed to find out how positive or negative or neutral is that piece of text, that document, towards that topic. And by the way, I forgot to mention, there are many ways in which the actual numbers, the sentiment scores are assigned. A lot of companies chose, for reasons of simplicity, to do some variant of positive, neutral, negative. It could be strongly positive, positive, neutral, negative, strongly negative, or some other shape, but it's typically bucketized, right? A small number of buckets. There are other solutions that actually give you a contiguous spectrum, say from -1 to +1. And they will say that opinion, the sentiment expressed in this document towards this topic is -0.73. And it is then up to the client application or up to the client himself to figure out how he wants to stratify this. Does -0.63 mean negative? Does it mean strongly negative? It varies from market to market. It varies from community to community because some people, some communities are hyper, typically, and their opinions are all very strong. They're either very negative or very positive, and there are few neutral opinions there. There are some other communities where people are, I guess, intentionally a little bit more subdued. So there are no spikes, there are no steep drops. They're all kind of, I guess, they're all very British. Let's put it this way. Okay, so let's look at this example that I have on the screen. The intense emotions of this landmark day and the historic weeks leading up to it are compellingly conveyed by the hypnotic music of Philip Glass in this highly anticipated world premiere. The good thing about this is that you don't need to understand what it is about. You could just do pure text analysis, and it will work for our purposes here. So the term that we are going to be examining is Philip Glass, who is a composer. Right? So obviously, this text expresses a fairly strongly positive opinion of his music. So step one would be to eliminate all sentences from the document that do not directly or indirectly reference the topic. In this case, since it's an artificial example, we only have one sentence and it is relevant. It talks about Philip Glass. But if you were looking at a larger document that was talking about music life in New York City, this may or may not be a relevant sentence. Now, now that you have your relevant sentences, the software needs to identify the opinion expressing constructs. So in this case, it's compellingly conveyed, hypnotic music, and highly anticipated. The easiest way to do it is you just look for adjectives that are typical, the basic opinion expressing words. There are adverbs also play an important role as well. So identify all the opinion expressing constructs or phrases, as they're called in the presentation, that you have in the sentence. So sentence by sentence basis. Okay. Now identify occurrence and polarity of opinion expressing phrases, right? So I changed this example a little bit just to show how the polarity could easily be changed, right? So the top one, the original example, says compellingly conveyed by the hypnotic music, blah, 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 blah. The second one differs in one word. It says not compellingly conveyed. So obviously, in the latter case, we say that the opinion expressing construct occurs negatively rather than positively, as it does in the first case. Then you identify, now that you have identified your opinion expressing constructs, you need to assign scores to each such construct. And there are various ways of doing it. One that is most often used is use of a scored term bank, right? You have a large collection of adverbs and adjectives that were somehow scored. For example, highly, right, may have a positive score of 0.5, whereas compellingly may have a positive score of 0.7. Whereas badly, for example, or poorly, will have negative scores. And we'll go a little bit into how these are modified, how the scores are modified by in various constructs. But the sum of these scores basically would represent a sentiment score expressed by this sentence toward the target topic. So, as I said, there are several ways to take into account the opinion expressing contract scores as applied to this main topic, to the search term. And one of them is the binding strength. So if you look at the example, so hypnotic music of Philip Glass, right? So hypnotic music is directly bound to Philip Glass. So let's say that this one will convey its score with a weight of 1. Compellingly conveyed also binds to Philip Glass because it binds to the music, and music in turn is bound to Philip Glass. But the length of the path is longer, so the strength of the binding is less in this case. So the score of compellingly conveyed will be applied with a lower weight. Highly anticipated is even less strongly bound, so its contribution to the overall score will be even smaller. There are ways to automatically do it. You can build what is called link graphs, which is a data structure representing the grammatic structure of the sentence. There are ways to assign the strength and to measure the strength and the length of a link of any particular word or combination of words to any other word in the sentence. Okay, so as I said, the end result should be the aggregation of these modulated scores, right? And so also worth keeping in mind that a sentence could be talking about 2 or more topics and could have completely different sentiment toward each of those topics. Especially when you're talking about, for example, competing products. Somebody could say, I love my iPhone and Samsung phones are crap. It's the same sentence, very positive on iPhone, very negative on Samsung. Could be the other way around. So if you are looking for the overall sentiment of the document, it's somewhat less precisely defined because you need to identify all the topics. You need to get the sentiment scores for each of the topics, and then you need somehow to combine them. But even when dealing with one topic, in a document of significant length, you could have positive and negative sentiment sentence towards the topic. There are ways of combining these scores. The simplest way is you just take the average. There are more advanced approaches where you could, for example, for each sentence also calculate the relevance of that sentence towards the topic. and use that as a weight. So the more relevant the sentence is, the higher the corresponding score contribution is. So I kind of ran a little bit ahead of myself, talking about aggregation. So how do we talk? I basically explained the things that we do. So in what follows, I want to go over some examples, basically looking at how scores vary, how different words in the sentence may affect the score of that particular sentence. If at the end you decide that you are still interested, we may schedule another presentation where I'll go into more details, covering what we do, how the document level scores are calculated.
Sorry, I have a question. I don't know if it's
go ahead.
Yeah, to interrupt you. I mean, so we can have like opinion score, and the sentiment can, in your explanation, if I get you correct, we have like a score from -1 to 1, and the sentiment can be like either positive or negative, right? So
yes.
Basically the question is, what if we need to get some other sentiment from not only like the positiveness or negativeness of the sentence, but what if we want to get some concrete, I don't know, like and if this sentiment is about angry or about is about more sad or fun, I don't know,
Right. So remember at the beginning I mentioned that the border between sentiment and emotions is getting less and less defined, right?
Okay.
So what your anger is more of an emotion, right? So and you could say, I don't like politician X because his policies make me angry, right?
Yeah.
The emotions typically, sorry, in our approach, and there may be other approaches. In our approach, emotions are actually scored a little bit differently. We are looking at the intensity of emotions, and we divide them in positive and negative, because there's anger.
Sure.
Anger is very rarely positive, right? Anger is almost always negative. So what we need to do is to calculate the intensity of that anger.
Yeah, so namely you can like calculate the intensity for each separate emoji, like the sentiment of all emojis, right?
Oh, well, if we're going to go into emojis, it's a whole separate conversation. But yes, sure, we can calculate sentiment of every emoji in there. There are certain specifics that if you really are talking about, the what is popular today is the graphical representations, right? The smiles and also a variety of emoticons and emojis that exist. Typically, those are really approached more via a machine learning solution, where you get a large enough annotated corpus, and you see, which emojis are perceived by humans as being positive or negative.
And sorry, one more question.
Sure.
If emojis detection is more task of machine intelligence, so sentiment, for now, it's not very clear for me how does the sentiment analysis, your sentiment analysis algorithm work? Like, is it like based on some statistics statistical approaches, or is it just analytical? I don't know, just hard to understand how does it work in real world or in code maybe, just slightly maybe.
Right. I wasn't really planning to show any code, to be quite honest, but
yeah, of course.
Right. The solutions that I'm describing here is a hybrid. It is using the NLP techniques to identify the opinion expressing constructs and their bindings to the topics. But the scores for these constructs were actually product of a statistical process. So how positive is the word bad? Or sorry, how negative is the word bad, right? And in order to accurate, or how negative is the frown face emoticon? Right? In order to do that, you need to analyze a fairly significant number of documents. And since we are trying to emulate human behavior here, the best way to produce results that are understandable to humans is to have an annotated corpus. So you have a large enough corpus that was annotated by, I don't know, 200 people. You could start doing some statistical inferences there, saying that, you know, bad, typical, probably compared to horrible is less intense. So you assign a value of about, you know, I believe bad in our situation is 0.7 and horrible is about 0.85. What you're trying to do, you know, the other component is you show a person a document and give him a topic, and you say, so how positive on the scale from -1 to +1 this document is towards this topic, and the human gives you this a value, right? Fairly arbitrarily, but expressing his or her perception of the strengths of the opinion. And if you have enough of those, you could actually solve that. Look at the opinion expressing constructs that were present, and you could get some values that would together give your system the ability to to get the same score for the document. I don't know if I explained it well, or if I just made it even more fuzzy.
No, it's okay. Thanks a lot.
Okay. By the way, I don't know. I probably should have done it at the beginning. Could you maybe describe to me whom I'm talking to, and basically how the audience are you guys all developers?
Most of them are.
Yeah, and actually for now, I and Dennis were building something like the classifier for emojis.
Okay.
Yeah, we're trying to predict the data, the emojis, real emojis, you know, from the mobile phones, so on, based on some Twitter data. So that's why I'm just wondering about all this stuff in depth, a bit in depth, you know.
Give us about 2 months. We are almost done with a paper where we're describing something fairly similar.
Oh.
Well, not that. Well, no, we're not looking at emojis. We are trying to do something a little bit more generic. And you're probably familiar with all this, you know, something to vector.
Yeah, word to vec. Yeah.
Word to vec. There is a tweet to vec, right?
Yeah.
And we are trying to generalize it to short text, so short to vec. And our goal there is a little bit different. We're actually trying to, the original goal was to predict the likelihood that two people are actually friends on Twitter.
So you're trying to generalize the building of this vector space.
Yes. Mm-hmm. For not just for tweets, but for
of course.
short text, right? And I'm not talking about. I wasn't planning to talk about this today, just because it is probably a bit too technical for me, even. When my developers talk to me, if they could make it, if I understand it, it means that they have explained it really well. There are folks who do them, data scientists who do it for a living. They're different species. I understand about 7 out of every 10 words.
Got it. Yeah, of course. We just wondering some general stuff for now.
Right.
Yeah.
But in general, the emoticons are, again, comparatively new phenomena. And we were very, very happily analyzing just pure text for a while. And then we were, originally we built a system to analyze larger documents with well-defined sentences, so news articles in particular, right? That's why, we are relying, for example, on a well-defined linguistic structure. If you go to Twitter, this whole assumption goes out of the window, because very often there is no grammar. Very often there are misspellings. Sometimes there are intentional misspellings. Sometimes they are accidental misspellings. They rely much more heavily on emoticons. So we had to basically redo the system. I mean, I wouldn't say from scratch, but we had to rip out about 50% of the code that was doing the heavy-duty sentence structure analysis. And then we had to move to more of a machine learning approach, where we were just training on large number of tweets. Obviously, the results are probably less precise, but at the same time, you get the results for each individual document are less precise, but the number of documents is higher. So again, statistically, we are probably about the same place where we were with like full text documents. We assume we have very interesting customer base these days. 99% of our revenue, well, 98% of our revenue comes from government agencies, from the US federal government agencies.
It's quite unexpectedly, actually.
No, why? They are interested in the same things any large corporation would be interested in, and then some, right? So they want to know how opinion spreads in social network. They want to know how to counteract misinformation campaigns. I suspect that they want to know how to run misinformation campaigns as well, but we're not doing any classified work at this time. But one of the things that, not US government actually, but we were working with the government of an Asian country that will remain nameless, and they asked us whether or not we could do analysis of text of SMS. And here in the US, legally getting access to SMS traffic is probably next to impossible, whereas in other countries it's easier. And they gave us some data, and again, they look like tweets in that there is often no grammatic structure to text messages, but at the same time, the language is very different. Links, for example, are rare. So it has its own specifics. Twitter is, well, I hope that Twitter stays popular and healthy for years to come, even though it's getting less and less popular, because Twitter is essentially a gold mine for anybody who wants to do large-scale data analysis. They provide access to their data fairly easily. There's a lot of it, so on and so forth. Compared to Facebook, by the way, where getting access to data feeds is extremely difficult.
Yeah, because they have their own researches, and they are working on the data and they don't want to share to everybody.
But it's also a matter of policy. Twitter also has its own researchers, but they made the decision that they will make this data available. You could get a lot of Twitter for free. You cannot get all of it for free. Full Twitter feed is very expensive, and I only know of 3 companies that actually process full Twitter feed. Anyway, so sorry, we kind of a little bit digressed, and we now have about 7 minutes left. Now I need to figure out what.
I'm sorry for that.
Well, so far you are the only person with questions, so I guess you are interested really in this topic, or at least you have concrete defined interest in this topic, whereas the rest of your team is still trying to figure out what this is about.
Yeah, we have 2 people who are directly involved in a kind of similar task. For everyone else, it's more like a generic education rather than specific knowledge.
Got it. So my problem is that I cannot really go much past our original. So I now need to figure out what do I skip. So I'll skip some of the examples. Let's do this. So this is very simple, right? The concept was good. The concept was good. The concept was bad. Positive, negative, easy, right? Now let's add adverbs. So hardly, really, absolutely, possibly, so on and so forth. The picture becomes more interesting, right? So the concept was good is positive. The concept was really good is even more positive. But if the concept was marginally good is less positive. But if you look at the concept was bad and the concept was really bad, right? So the situation changes, right? The concept was bad is negative. The concept was really bad is more toward that end. So the really is a intensifier. It's a strengthener. It strengthens either positive or negative opinion. What do we want to skip here? Okay, this one will skip. This one will skip. In addition to adverbs, you could actually look at adverbs and verb combinations. There are various ways to characterize the verbs, and there was actually a very good book written, I think, in the 70s by a person named Beth Levine, who introduced this classification. We modified it a little bit to fit our purpose more. So if you take these verbs into account, you will see that he said that the concept was good. It's a positive thing. It's probably less positive than if you just looked at the concept was good, because it implies some degree of indirection. He reiterated that the concept was good is much more positive than he said the concept was good, because reiterated implies emphasis on whatever opinion the person had. He strongly reiterated, obviously, is even better. And the reverse works when you are dealing with the negatives. Okay. So there There are many tools that people use. Stanford Core NLP is a great free, semi-free tool. Depends on what you want to use. You want to use it for. Gate from the University of Sheffield is an excellent toolkit, especially if you are looking at entity recognition. Hard to use though. Stanford is a little bit easier to use. LinkPipe is universally acknowledged for their API. And obviously today, everybody is working with Python, and Python has lots of modules and libraries and their NLTK kit. I think today, even when we started with our software all being written in C++, we then moved to Java because we needed a little bit more portability. Today, about 70% of our stuff is written in Python. Yes, there was some performance hits, but the convenience outweighs. You could always put another server. It's cheaper than spending 3 weeks of developer's time.
Sorry, are you using R in production maybe somewhere?
No, we are not using R in production. I know people who do. But we decided, and at this point, we decided that we're not using R. Probably, just naturally, because the teams that we have, they are Java and Python experts. They have some understanding of R, but relatively little.
May I ask a question?
Sure.
Are there some other disadvantages of using R in production? Maybe some low performance or memory issues or so on?
I honestly don't know, since we're not using it. And our decision not to use it was not based on known performance issues. I know a company next door to us, essentially, that uses R. They are not dealing with huge data volumes. They love R. They basically swear by it. They say that it's the greatest thing ever. I don't know if there are any scaling issues. I just never had to deal with it.
Thank you.
Sure. So, sorry, go ahead.
No, я просто хотел сказать, что если ты должен идти, то я просто хотел поблагодарить тебя.
Я закончу. У меня осталось 2 слайда. Я закончу, и тогда с чистой совестью пойду.
Okay.
So challenges. We talked about Twitter, which is totally different from everything else, right? But if you're just looking at, it doesn't even matter what sort of documents you look at. Context. You need to understand the context. And my favorite one is about the Kalashnikov rifle. So if the sentence says that AKM is the best, deadliest weapon on earth, is it positive or negative? It really depends on the audience, right? Whom we are talking to. For people who are trying to sell it, it's positive. For people who are against wars and violence, it's probably very negative. Comparisons are hard because, for example, the sentence, iPhone camera does not compare to professional cameras. Is it positive or negative for iPhone? Yes, there are contexts in which it is probably negative. But if, for example, people are talking about how heavy the equipment is, this isn't necessarily such a negative thing. Sarcasm is the hardest thing. I know that people, like every half a year, somebody claims that they have solved the sarcasm problem. I haven't seen a solution that actually consistently solves it. So, maybe it's just so inherently human that it's not possible to be an algorithm. And if somebody says that's just perfect, is it positive or negative? Right? In conversation, you rely on the tone of voice. Yeah, right is fodder of many jokes, right? And where essentially two positives make a negative here. Many фразеологических оборотов там, and slang also is difficult. Humor is next to impossible. And again, people are very actively working on all of this, and I'm sure that small progress is being made every day. And it is also very interesting, and it was very interesting to watch when we started. And you go to a conference and you say, our tool generally on average is 0.67% accurate. Back in 2006, if you said that your tool was 80% accurate or more, whatever it means, nobody would have believed you. Today, if you go to a conference and you say my tool is X% accurate, if X is less than 85%, nobody would listen to anything else that you have to say. It's expected.
Interesting fact that regarding to emoji prediction, we achieve top 1 accuracy. So first predicted emoji of our models, right? We achieve 10%.
10%? Yeah.
10, yeah.
Last year, sorry, no, the year before, not 2016, 2015. So every year there are 2 conferences, sometimes 3, that are dedicated to sentiment analysis. And 2015 was the first year when a guy from Stanford, I think, came and talked about the emoji and their role in future sentiment analysis. He didn't talk about accuracy, but the main message of his presentation was, guys, you thought your life was hard. It's now about to get much harder. We haven't tried really. And it will be interesting to see what we can do with emojis. So typical applications we talked about, but there are somewhat less typical things that we have done, maybe because of the specifics of our customer base. How do opinions spread in social networks? If I, for example, say something about sentiment analysis software, more people are likely to believe me than if I were to talk about, I don't know, latest fashions, for example. On the other hand, if some TV celebrity were to talk about fashion, his or her probably opinion would be much more influential than if she were to talk about sentiment analysis. So topic-specific influence measures are of great interest, not only to federal government agencies, but more and more to marketers and to companies in general, because they are trying to build this communities. It's good if somebody influential says something good about you. The tried and true traditional approach is, you give this person something, like you give him your new phone and he says something good about this phone. But how many phones can you give out, right? So people are trying to optimize this by figuring out who are influential people for particular areas of expertise and how to spend the least amount of money and achieve the maximum coverage. So if 2 people are very influential, but they're all followed by the same crowd, there's almost no reason to go for both. Whereas if there are 2 people who are somewhat less influential, but their followers are completely disjoint, if you somehow convince both to say good things about you, you get more bang for the buck. Another problem is bots on Twitter in particular. There are various estimates as to how many bots there are, but all the estimates are high. And it turns out that you could use sentiment as one of the tools in detecting bots. The distribution of sentiment by programmatic entities, by bots, is different from that of human beings. And sentiment consistency is also different. Now going back to emotions, there are some very interesting things happening in using text and voice analysis for excuse me, diagnostics of various conditions. And obviously the start of it was mental health evaluation. And the stuff that we did there, I mean, I'm not claiming that we're the best, but we did some stuff in there. It turns out that people with post-traumatic stress disorder use different language patterns. Their express different emotional signals, even in written documents. You could use the same thing for workplace stress and other things. For example, internal threat detection. There are some indications, and it's, well, it's not exactly global monitoring, not Big Brother, but getting close to it. You can monitor, say, internal emails and try to figure out if an employee X is very unhappy in his or her position and is stressed. And those two factors often are precursors to worse things. Not always, but what else? One of the health, we started with mental health, but now people are saying that one can predict many other conditions. Some of them have to do with brain damage. Some people claim that they could detect they could evaluate the risk of heart disease, for example. I don't know. That's not quite sentiment. It's more emotions, and it also has to do with probably just acoustic analysis, which is different from this topic. Anyway, so sentiment analysis, as I said, is by now an old problem. Everybody likes to think that this has been solved. But there are so many unknowns still in there that there's a lot of work, and there's a new player. Every quarter there's a new company saying, well, we have developed this over the last 10 years, come try it out. I hope, well, as I said, I didn't quite know who my audience was, so I tried to make this probably less technical than I should have. I hope it wasn't completely boring.
Yeah, it was cool. Thank you very much.
It was very interesting. Thank you.
Спасибо большое, Дима, за твое время. Огромное спасибо.
Garik, my pleasure.
Окей.
Хорошо.
Спасибо.
Спасибо вам.
До свидания. Спасибо, до свидания.
Извините, вопрос еще такой. Когда вы сделаете ресерч, где вашу статью можно будет поискать? Или это приватность?
Нет, мы ее опубликуем, я надеюсь. Я Гарику сообщу, где она будет опубликована. Я еще не знаю, куда она попадет.
Спасибо большое.
Окей, замечательно. Спасибо.
Хорошо. До свидания.
Хорошего дня. До свидания.